Hello there, and welcome to Just About Space. Tonight, as you sit in the quiet of your room and the hum of the world fades into the background, I want you to imagine something larger than your own life, larger than our planet, larger even than the galaxy. I want you to imagine the possibility and the weight that we may be the last civilization the cosmos will ever see. It is a thought that unfolds slowly, like the first light of a distant sunrise touching the surface of a frozen world. At first, it's simply an abstract question, something philosophers and astronomers might bat around in university corridors or during late-night observatory shifts. But as you begin to think about it, to truly hold it in your mind, it takes on a gravity of its own. If the universe is 13.8 billion years old, and if stars have been forming since the earliest chapters of cosmic history, then life, intelligent life, could have emerged long before us. And yet, we see no sign of it. Our telescopes, from the earliest backyard lenses to the great orbital eyes we've launched into the void, have scanned billions of stars. They've searched for radio signals, chemical signatures in alien atmospheres, unnatural patterns in starlight that might hint at megastructures, and they have found nothing. Not one confirmed message, not one unambiguous beacon of intelligence. We call this the Great Silence, but there's another name for it, more unsettling: the loneliness of the long now. The sense that perhaps the universe is not teeming with civilizations waiting for us to join them, but instead nearly empty. And in that emptiness, maybe we are not just early explorers, maybe we are the final witnesses. Think of the arc of time on a universal scale. Stars form, burn and die. Galaxies collide and drift apart. Physics itself sets a timer, entropy, that will eventually scatter all order into chaos. The time for life is finite, and the odds of intelligent life forming are, as far as we can tell, slim. What if the window is closing? What if countless civilizations have already risen and fallen, and we are among the last embers flickering before the dark? This question is not about ego. It's not about being special. It's about responsibility. The weight of knowing that if we are among the final conscious voices in the universe, then our survival, our culture, our knowledge becomes the universe's last chance to know itself, before the silence becomes permanent. And yet, there is an even sharper edge to this thought. Perhaps we are already too late. Perhaps the cosmos has long passed its golden age of civilizations, and we are wandering through a cosmic graveyard, one of the few remaining lights that will eventually burn out. Tonight, we'll explore this question, scientifically, philosophically, and with the strange intimacy that comes from imagining yourself not as a single human on a small planet, but as a temporary spark in a vast darkness. The question remains, hanging above our heads like a cold star: are we the last civilization the cosmos will ever see? If you could stand in the vacuum between galaxies, billions of light years from the nearest sun, the first thing you'd notice is the absence of everything familiar. No air to breathe, no ground beneath your feet, no birdsong, no engines, no human voices carried on the wind. Only silence, stretching out in every direction, eternal and absolute. But the strange truth is that even here on Earth, surrounded by the endless chatter of human civilization, we are still bathed in that same silence, the cosmic silence. The silence that persists no matter how hard we listen. For decades, our instruments have been tuned like violins straining for a single perfect note. Radio telescopes sweep the skies in search of narrow-band transmissions, the kind of signal nature does not make by accident. Optical arrays watch for sudden flashes or unnatural patterns in starlight, as if catching the wink of a cosmic lighthouse. We've scanned the nearest 100 stars, then 1,000, then tens of thousands. We've probed the galactic plane, stared deep into globular clusters, and aimed our antennas toward the faint smudge of the Andromeda galaxy. Nothing. This is not the nothing of not looking hard enough. This is the nothing that remains after decades of searching, refining our methods, and eliminating false alarms. In 1977, there was the wow signal, a sharp, unexplained burst that for 72 seconds made astronomers believe this could be it. But it never repeated. It never explained itself. It never came back. We are left with a scrap of paper with the word wow scrawled in the margin, and the silence resumed. Some argue the silence is deceptive, that civilizations may not be broadcasting at all. Why would they? We humans only began sending out detectable radio signals about a century ago, and already we're abandoning them in favor of tightly focused communication methods that don't spill into space. If alien civilizations evolve quickly towards such methods, their detectable phase might last only decades, a blink in cosmic time. That's like expecting to catch sight of a single match being struck in the middle of an ocean on a stormy night. Others say the silence is a warning, that civilizations which broadcast openly may invite danger, the hunter and the hunted, playing out on a cosmic scale. Perhaps those that survive learn to keep quiet. Perhaps survival means vanishing into the background noise, hiding among the static. But there's another possibility. Darker still, the silence may not be a matter of choice. It may be the result of inevitability, that civilizations tend not to last long enough to sustain a conversation across interstellar distances. In this view, the universe is filled with the ghosts of cultures who might have spoken to us if we both existed at the right time, but whose voices were extinguished long before ours rose. And here's where the loneliness sharpens. If the universe was once loud, full of signals and transmissions and visible signs of intelligence, then our moment is eerily late. We might be living in the tail end of cosmic history when life capable of communication is no longer common. We may be inheriting the graveyard, walking among the tombstones without even knowing whose names are carved into them. The silence isn't sect empty. It's sects full of questions. Questions about our place, about our timing, about the brevity of intelligence on a cosmic clock. When we point a radio telescope toward the stars, we're not just listening for voices, we're asking if there's anyone left to hear ours in return. And so far, the answer seems to come back the same way every time. Not in sound, not in words, but in the persistent absence of both. A silence that is more than the absence of noise. A silence that feels like an answer in itself. A silence that asks us, "Are you the last?" It began, as many unsettling truths do, with a deceptively simple question. A summer afternoon in 1950, Los Alamos National Laboratory. The air outside was dry and sun-washed inside. A group of scientists, men who had helped shape the atomic age, were chatting over lunch. The conversation drifted from cartoons to UFO reports to the practicalities of interstellar travel. Then, in the middle of the banter, physicist Enrico Fermi set down his fork, looked up and asked, "Where is everybody?" It was not a joke. Fermi, whose mind could turn from nuclear chain reactions to cosmic timescales without missing a beat, had just cut to the heart of a paradox that would outlive him. If the universe is old and vast, if the laws of physics are uniform and predictable, and if nothing forbids life from arising on other worlds, then where are all the other civilizations? Think about it. Even using cautious assumptions, the galaxy should have had more than enough time for intelligent life to appear, develop technology, and spread not just to a few nearby systems, but across the entire Milky Way. At speeds far slower than light, a determined species could, in theory, visit or colonize every habitable planet in the galaxy within tens of millions of years, a blink on the cosmic clock. And yet, here we are, billions of years into that clock, surrounded by a silence so total it almost feels intentional. This is the Fermi paradox, a whisper that has echoed through the corridors of astronomy and philosophy for 75 years. It is not a mystery we stumbled into by accident. It is the direct result of looking at the numbers and realizing they don't add up. Imagine the Milky Way, a disk of 100 to 400 billion stars, many of them older than our sun, many with planets in the habitable zone where liquid water and perhaps life could exist. Now extend this to the entire observable universe, 2 trillion galaxies, each with billions of stars. If even a small fraction of these worlds birthed intelligent life, we should, by all probability, be tripping over evidence of them. Cities etched into the surfaces of planets, megastructures siphoning energy from suns, signals crisscrossing space like a web of light. But instead, nothing. And that nothing is deafening. Some have tried to soften the paradox with optimism. Maybe life is common, but intelligence is rare. Maybe intelligence is common, but technology is rare. Maybe technology is common, but the desire to explore or communicate is rare. Each maybe is a way of pulling back from the edge of the darker possibilities, the ones that say civilizations tend to self-destruct or are destroyed by forces beyond their control before they can leave a lasting mark. Others lean into the darkness. They suggest that there is a great filter, some catastrophic threshold that almost no civilization passes. Maybe it's in the past, and we're one of the lucky few to survive it. Or maybe it's in our future, waiting for us in some form we can't yet imagine. Climate collapse, AI rebellion, cosmic disaster. If that is true, the reason we don't see others may be that they've all hit the same wall, and we're racing toward it ourselves. There's also the chilling idea that the silence is not a natural outcome but an enforced one. What if the universe is more like a dark forest, where every civilization is a hunter, and every signal you send is a flare revealing your position? In such a forest, the safest strategy is to remain quiet, invisible, and hidden. Maybe the civilizations that survive are the ones who never announce themselves, and maybe the ones who do are quickly removed. Yet there is another side to the Fermi whisper, one that isn't as fatalistic. It could be that life is rare not because it's doomed, but because the conditions for it are fleeting. Stars burn out, planets lose their atmospheres, galaxies drift apart, making communication between them nearly impossible over vast timescales. Perhaps we are simply living in the late afternoon of the universe's habitable era, too late to meet most of our cosmic neighbors, too early to watch the final embers fade. And here's the part that twists the knife. If that's true, then our existence right now is more significant than we care to admit. If we are one of the last intelligent civilizations the universe will ever produce, then every story we tell, every discovery we make, every monument we build is part of the final record of consciousness itself. Fermi's question still stands. It is not answered by optimism or pessimism, only by the persistent, unnerving fact that the stars remain mute. You can look up on a clear night and see thousands of them with the naked eye, each one a sun in its own right. Statistically, some of them should host life. Some of them should have seen empires rise and fall under their light. Some of them should be sending signals still, but they are not. It is the oldest question in the modern search for extraterrestrial intelligence, and it will likely be the last. If the universe should be full of voices, why is it so quiet? And under that question, like a whisper between the stars, another thought. Maybe the reason we hear nothing is because we are the last ones left to speak. There is a certain weight to the idea that the universe has already made up its mind about the fate of intelligent life. We just don't yet know which way the verdict falls. This weight is what scientists and philosophers have come to call the Great Filter, a hypothetical barrier in the development of life, one so difficult to cross that almost no civilization in the history of the cosmos has made it to the other side. Picture the entire history of the universe as a long, uneven path stretching from the first atoms to the furthest possible future. Along this path are milestones: the formation of stars, the creation of planets, the appearance of life, the emergence of intelligence, the rise of technology, the mastery of interstellar travel. Somewhere along that chain, there is a step that is almost never taken: the Great Filter. It's the reason we see no signs of galactic empires, no alien beacons, no ancient ruins on far-off worlds. The trouble, the haunting, sleepless trouble, is that we don't know whether the Great Filter is behind us or ahead of us. If it's behind us, the silence becomes a strange kind of comfort. It would mean that the appearance of intelligent spacefaring civilizations is so rare that we are one of the few, maybe the only, to ever emerge. Perhaps life itself is vanishingly improbable, or complex multicellular life almost never forms, or intelligence capable of building radio telescopes is a statistical miracle. In that case, our very existence is evidence that we've already passed the test. We've crossed the barrier that stops almost everyone else, and the galaxy is quiet because there was almost no one else to begin with. But if it's ahead of us, then the silence is a warning. It would mean that somewhere in the steps we've yet to take, perhaps in the next century, perhaps in the next millennium, lies an event, a tendency, or a pitfall so universal that it claims nearly all who reach our stage, a wall we cannot yet see. What could it be? The possibilities range from the banal to the terrifying. It could be environmental collapse, civilizations growing too fast for their planet's resources to sustain them, choking on their own industrial byproducts. It could be self-destruction through war, perhaps with weapons we can scarcely imagine. It could be technological catastrophe, where an artificial intelligence once created becomes indifferent or hostile to the beings that built it. It could be something cosmic, a gamma-ray burst sterilizing a swath of the galaxy, a rogue black hole sweeping through a populated region, or a cascade of supernovae wiping out biospheres before they can recover. Or perhaps the great filter is something subtler, something woven into the psychology of intelligent life. Maybe advanced civilizations always turn inward, becoming obsessed with simulated worlds and digital pleasures until the outside universe is forgotten. Maybe they simply lose the will to expand, to endure, to survive. Maybe intelligence itself carries the seed of its own collapse. The philosopher Nick Bostrom put it starkly: finding microbial life elsewhere in the solar system, on Mars, Europa, Enceladus, would be bad news. Why? Because if life arose easily more than once in our own neighborhood, it means the early steps forming life at all are not the filter. That would push the filter further along, toward the steps we have yet to take, increasing the odds that it lies in our future. By contrast, the more rare life appears to be, the more likely the filter is behind us. It's a grim kind of calculus, rooting for the universe to be mostly dead, so that we might live longer in it. The Great Filter also reframes our search for extraterrestrial intelligence. Every silence we encounter is a data point. Every absence of signal hints that the filter is real, and that most others have failed to pass it. If the filter is ahead, our current age, the age of radio, rocketry, and global networks, might not be the dawn of our cosmic journey, but the prelude to our extinction. And here's the paradox inside the paradox. Knowing about the Great Filter might give us the power to avoid it, if it's ahead of us. Self-awareness could be our one advantage. By recognizing the potential for collapse, we might steer away from it. But this assumes the filter is something that can be navigated, something within our control. If it's a fundamental law of biology, physics, or psychology, then awareness may change nothing. The wall will still be there, and we will still be racing toward it. Standing under the night sky, it's tempting to imagine that our survival is inevitable simply because we've made it this far. But the Great Filter reminds us that survival is not guaranteed, and the silence of the stars may be the collective epitaph of countless civilizations who once believed the same. Perhaps we are the lucky few who already passed the trial, or perhaps we are the next in line for the long, unbroken silence. Either way, the question it asks of us is one we cannot ignore. If the filter is ahead, can we see it in time? The stars will not answer. The universe offers no reassurance. The only thing we can be certain of is that the path forward will be shaped by choices we have not yet made, and that the echo of the Great Filter will follow us with every step. If you could condense the entire history of the universe, all 13.8 billion years, into a single calendar year, something strange would leap out at you. Life on Earth wouldn't appear until early September. Complex multicellular organisms, mid-December. Dinosaurs would strut across the stage for just a few days before vanishing on Christmas morning. And modern humans, our species, with our tools, languages, and capacity for abstract thought, would only show up in the final few minutes before midnight on New Year's Eve. In that compressed scale, our existence as a thinking technological species isn't just brief. It's a flash, a flicker, the striking of a single match in the darkness. And in that flash lies the uncomfortable truth. Intelligence may not be a permanent state. It may be an unstable phase, a narrow and fragile window in the life of a planet, one that closes almost as soon as it opens. We like to imagine intelligence as inevitable. Once evolution starts climbing the ladder of complexity, we picture it as a mountaintop, a final, triumphant state. But perhaps it is not a mountain at all, but a tightrope strung over an abyss, swaying in the wind. Walk it too fast, you fall. Walk it too slow, you fall. And even if you cross, there's no guarantee the rope will hold forever. Consider how easily this window could have failed to open for us. The Chicxulub asteroid that ended the reign of the dinosaurs 66 million years ago could have missed Earth entirely, leaving mammals in the shadows. The genetic mutations that shaped our brains could have unfolded differently, leaving us clever but never self-aware. Our ancestors might have remained nomadic tool users, never developing agriculture, cities, or writing. But even after it opens, the window is precarious. We've been capable of radio communication for just over a century. In that time, we've come within a hair's breadth of nuclear war, degraded our climate in ways that threaten our survival, and built technologies powerful enough to end our civilization if misused. The balance between our intelligence and our instincts, between our capacity to build and our tendency to destroy, is delicate. Now imagine this fragility. On a cosmic scale, what if most planets that give rise to intelligent life do so only briefly? Maybe civilizations rise, explore, and vanish within a few thousand years, an instant compared to the age of the stars. If that's true, then the odds of two civilizations existing at the same time and being close enough to communicate are extraordinarily low. The universe could be full of intelligent life, just not all at once. It's like watching fireflies on a summer night. In the dark field of the cosmos, each firefly is a civilization. They blink on for a moment, bright and full of potential, then wink out. The odds of two blinking in the same moment, close enough to see one another, may be vanishingly small. And perhaps right now we are blinking, alone. This idea reframes our search for extraterrestrial intelligence. We might be listening for signals not because they are absent, but because they have already faded. By the time we detect a civilization's transmission, they may already be gone, their cities crumbled, their oceans reclaimed by silence. We may be sifting through the echoes of voices that no longer exist, like archaeologists of the sky. It also means our own signal, the thin bubble of radio and television broadcasts expanding at the speed of light, is a fragile beacon. In another century, perhaps even sooner, we may stop emitting such signals altogether, replacing them with tight beam communications invisible to the wider galaxy. Our shout into the universe will become a whisper, and then silence. The window will close, at least in terms of detectability. Some scientists see this fragility as a kind of natural selection at the cosmic level. Only civilizations that learn to manage their resources, avoid self-destruction, and maintain the will to explore will endure long enough to overlap with others. The rest flicker out quietly, leaving behind no trace, but perhaps a thin layer of artifacts on their home world. Others think the fragility is inevitable, not because civilizations fail, but because the universe changes. Stars age, planets drift out of habitable zones. The chemistry that sustains life becomes unstable. Intelligence may have its time, but the cosmos is not built to preserve it indefinitely. And so, when we ask whether we are the last civilization the cosmos will ever see, part of what we're really asking is, how long will our window remain open? Will we find a way to keep it ajar for millennia, maybe millions of years? Or will we too blink out before our light has a chance to be seen? The stars will not answer. But the night sky in its cold beauty reminds us of the stakes. Every decision we make now, how we treat our planet, how we wield our technology, how we choose to expand or retreat, will determine whether we are just another brief flicker or a light that burns for as long as the cosmos allows. Our window is open now, but it will not stay open forever, and beyond it lies the silence. If the story of the universe has a single, unbroken thread running through it, it is this: entropy always wins. No matter how bright the star, how ordered the galaxy, how intricate the living system, the arrow of time moves in one direction, toward disorder, toward equilibrium, toward a final state in which all differences have been erased, and the universe becomes cold, dark, and still. Entropy is not malevolent. It is not a destroyer in the way we imagine destruction. No fire, no blade, no sudden collapse. It is patient. It takes the long view. It is the slow wearing down of structure into dust, the gradual bleeding away of energy, until there is no gradient left to power the dance of matter and light. In our daily lives, we see entropy in rusting metal, in fading photographs, in the way heat disperses from a cup of coffee into the room until both reach the same lukewarm state. On cosmic scales, it's the same law, played out across billions of years. For a civilization, entropy is both an invisible opponent and an inescapable horizon. Stars are the engines of complexity. They pour out light and heat, creating the conditions for chemistry and biology to flourish. But stars have lifespans. Our sun will burn for another 5 billion years, but the most massive stars, the ones that burn the brightest, live only a few million years before exploding into supernovae. The smaller, cooler red dwarfs may burn for trillions of years, but even they will eventually exhaust their fuel. And when the stars go out, the lights of civilizations, if any remain, will follow. In the far future, galaxies will stop forming new stars. The ones that exist will slowly die, leaving behind a population of white dwarfs, neutron stars, and black holes. Planets, if they still exist, will orbit cold embers. Energy will be scarce, and life as we know it will find no foothold. Even the black holes, which seem eternal, will eventually evaporate through Hawking radiation, leaking their mass back into the universe as faint trickles of particles over unimaginable timescales. This is the ultimate destiny. Physics points us toward heat, death, not an explosion or a collapse, but the slow, irreversible erasure of temperature differences until the universe reaches maximum entropy, a featureless expanse where nothing changes because there is no energy left to drive change. No stars, no planets, no life. For us, this seems impossibly far away, almost irrelevant to the present. But when we talk about being the last civilization the cosmos will ever see, entropy's shadow stretches over the entire conversation. The clock is already ticking, and no matter how far we project into the future, there is a finite amount of time before the universe becomes incapable of hosting life at all. Even if humanity somehow survives every local threat, war, environmental collapse, asteroid impacts, and even if we spread to other stars, entropy will still be there waiting, colonize 100 star systems, then 1,000, then 1,000,000. The stars will still age. The galaxies will still drift apart, their light shifting into the red, then into the infrared, then into wavelengths so long they become undetectable. Eventually there will be no way to see another galaxy at all, no way to send a signal that will be received before both sender and receiver are gone. Some theorists suggest there might be ways to stave off entropy's final claim, harnessing the energy of black holes, migrating to younger galaxies, even creating artificial universes, pocket realities in which new physical laws reset the cosmic clock. But these ideas belong to a realm so far beyond our current technology that they hover on the edge of science fiction. And even then, we must ask, are these escapes truly possible, or are they just clever ways of delaying the inevitable? Because entropy is not merely a prediction, It is built into the fabric of reality. Every atom, every photon, every interaction obeys its laws. You can work around it for a time, but you cannot win. And so perhaps the most sobering truth of all is this. The universe itself has a built-in expiration date for civilizations. Not just ours, but all of them. Every intelligent species, no matter how advanced, will eventually face the same end game. It doesn't matter whether they master interstellar travel, whether they upload their minds into machine bodies, whether they tap into energies we cannot yet imagine, the heat death will come for them too. It's not a dramatic ending. No blinding light, no cataclysm, just the slow extinguishing of possibility, the gradual cooling of the last star, the last thought, the last flicker of awareness. And if that is the fate awaiting every civilization, then there is a deeper question hidden inside our original one. Not just are we the last civilization the cosmos will ever see, but does it matter if we are, if the cosmos itself is destined to forget us? The only answer that makes sense, perhaps, is this: it matters to us. It matters because while entropy claims everything in the end, the present moment is ours. The time when the stars still burn, when planets still orbit in warmth, when intelligence still contemplates the sky, this is the rarest era the universe will ever know. If we are the last, then it is our privilege and our burden to make the most of it, to burn brightly, knowing that the darkness will one day be absolute, to speak, even if the silence will one day erase every word. The universe does not care that we are here, but perhaps that's why it's worth caring anyway. Before the last star burns out, before entropy takes its final quiet victory, there is another, earlier death awaiting every civilization, the death of connection. Long before the universe freezes into darkness, it will become impossible for one pocket of intelligence to communicate with another. The light will still shine locally, for a while, but the voices will be gone. To understand why, imagine the universe not as a static backdrop, but as a living, expanding thing. Since the Big Bang, space itself has been stretching, carrying galaxies away from one another. This expansion is not slowing down. It's accelerating, driven by what we call dark energy, a mysterious force woven into the fabric of reality. As space expands, the distances between galaxy clusters grow so quickly that eventually, light itself can no longer bridge the gap. Right now, we live in a connected era, with enough power and patience. A signal sent from Earth could, in principle, reach most of the galaxies we can see. The time delays would be immense, millions or billions of years, but in theory, the network of possible communication is vast. But in the deep future, this will change. Galaxies beyond our cosmic neighborhood will slip away faster than their light can reach us. They will disappear, not because they have physically vanished, but because the expansion of space will carry them beyond our cosmic event horizon. This is not science fiction. We already see it happening. Some galaxies we observe today are moving away so quickly that if they were to send a signal now, it would never reach us. The space between us is swelling faster than the signal can cross. From their perspective, we have already disappeared. We are ghosts in their sky. For a civilization, this shrinking horizon means that the window for intergalactic communication is finite. Right now, there may be distant intelligences within reach of our signals, but the longer we wait, the more of them will slip away, unreachable forever. Even if we do eventually meet others, the cosmic expansion will eventually isolate us into small, silent islands of matter. In a few trillion years, the Milky Way and its closest galactic companions will be the only structures left in our observable universe. All other galaxies will be gone from view, carried into the unreachable dark. This collapse of the cosmic conversation isn't just about distance. Even within a galaxy, communication has a cost. A message sent from one end of the Milky Way to the other takes over 100,000 years to arrive. Civilizations need not only the technology but the patience and the continuity to maintain such long-term exchanges. What society can hold a conversation lasting hundreds of thousands of years without collapsing, forgetting, or turning inward? And that's assuming that both civilizations are broadcasting openly at the same time, during the tiny overlap, when their technological lifespans coincide. The odds are slim. The more you think about it, the more remarkable it becomes that any two civilizations might speak to each other at all. It requires aligning across time, space, technology, and intent. And the cosmic expansion is steadily eroding the most basic requirement of all physical reach. One day, perhaps not so far on the cosmic clock, the night sky will look different. Instead of being littered with hundreds of billions of galaxies, it will be sparse, almost empty. Future astronomers, if there are any, will not see the great clusters and filaments of the cosmic web stretching into infinity. They will see only the local group, a handful of galaxies bound together by gravity. They will believe, perhaps, that the universe is small, static, and eternal, because all evidence of its greater scale will be gone. And if no other civilizations remain in that small patch of space, then the possibility of ever meeting another mind will be gone as well. The universe will not need to be empty to be silent. It will only need to be separated beyond communication. This is the slow isolation of intelligence. Not a war, not a disaster, but a steady retreat into solitude, imposed by the very structure of the cosmos. And the most unsettling part is this. If we are among the last civilizations, the collapse of communication means that, in the end, even if others exist, we may never know. We may pass the final centuries or millennia of our cosmic life, believing ourselves utterly alone, not because we are, but because the universe has locked the doors and drawn the curtains. In that sense, the question, are we the last civilization the cosmos will ever see, might have a second layer. We could be the last visible civilization, the last whose voice could reach others before the expansion closes the distance forever. And once that happens, the stars in our sky will shine only for us, indifferent witnesses to our fate. So perhaps the real question is not simply whether we are the last, but whether, even if we are not, the cosmos will soon make it so we may as well be. The night sky feels eternal. We step outside, look up, and see constellations we've known since childhood, bright points that seem as fixed and unchanging as the idea of forever. The same stars shone down on our ancestors 10,000 years ago. The same stars will still be here long after we're gone, or so it feels. But that feeling is a lie. The stars are not permanent. They are burning, consuming themselves, turning hydrogen into helium and heavier elements in nuclear furnaces, so hot that they warp the very fabric of space-time. They only look constant because our lives are short, and stellar time moves slowly compared to our own. If you sped the universe up like a film on fast forward, the stars would wink on and off like fireflies, each one a brief flare in the darkness. This is the stage of the universe we live in now, the stelliferous era, an age where galaxies are bright with billions of stars, where planets orbit in warm zones, and where life has a chance to take hold. But this era is finite. One day the stelliferous era will end, and with it the possibility of life as we know it. The first signs will come quietly. The most massive stars will go first, dying in spectacular supernovae that seed their surroundings with heavy elements. The smaller, steadier stars will keep burning, but each death is permanent. No new stars will replace them at the same rate. Star formation is already slowing across the universe. In our own Milky Way, the stellar nurseries, vast clouds of gas and dust are dwindling, used up by the generations of stars before. Over hundreds of billions of years, the balance tips. Young, bright stars become rare. Red dwarfs, the longest lived, dominate the sky, their dim light casting a ruddy glow over whatever worlds remain. Civilizations, if any still exist, will cling to these faint embers, huddling close to their warmth. These red dwarfs may burn for trillions of years, but even they will eventually fade into black dwarfs, cold, invisible cinders in the dark. When the last star dies, the stelliferous era ends, and the universe enters the degenerate era. From here, only remnants remain, Black holes, neutron stars, white dwarfs, and planets drifting without suns. The only light comes from the occasional flare of matter falling into a black hole or the brief, ghostly glow of a collision between two dead stars. It's easy to think that advanced civilizations might survive even this, tapping into the energy of black holes, mastering the fusion of light elements, or building vast artificial habitats to trap and reuse every scrap of available energy. And maybe they could, but the math is unforgiving. The energy budget dwindles over time, and each attempt to use it accelerates its loss. In the end, the last civilizations may live in conditions we can barely imagine, far from warm worlds huddled around engineered light sources, scraping power from the cosmic background radiation itself. And then, one by one, they too will fail. Even black holes have a clock on them. Through the slow process of Hawking radiation, they evaporate over timescales so vast they defy our sense of time, but vanish they will. The giants will go last, supermassive black holes taking up to 101010 circumflex 100 ahud 10100 years to fade. When the final one evaporates, the universe will be left with nothing but low-energy particles drifting in a featureless dark. This is the heat death, the point at which entropy reaches its maximum and no work can be done. No stars, no heat gradients, no chemistry, no biology, no thought. If we are the last civilization, then this horizon is not just the end of us, it is the end of everything. It means that when we are gone, there will be no more consciousness in the universe, no more eyes to watch the stars fade, no more minds to even remember they existed. The lights will go out, and the silence will be absolute. This realization changes the stakes of our existence. In a cosmos where the end is written into the laws of physics, every moment of awareness is an act of defiance. Every thought, every work of art, every discovery is a way of shining in the dark, if only briefly. If we are the last, then our duty, if such a word even applies in the face of cosmic inevitability, is to make our light burn as brightly as possible before the horizon closes in. But here is the cruel paradox. We will never truly see the heat death. It is too far away for any living mind to witness. It will happen in the farthest stretches of time, long after our atoms have been scattered. We live in an age when the stars still blaze, when galaxies still dance, when the universe is still young by its own measure. We can only imagine the final darkness, like sailors imagining the edge of the world they will never reach. And perhaps that is why the thought is so haunting. The heat death is not something we will meet. It is something that will erase us without even knowing we existed. For now, the lights are still on, but one day they won't be. And if we are the last, it will be our fate to carry the torch through the final chapters of the Stelliferous era, knowing all the while that when it slips from our grasp, there will be no one left to pick it up. Picture the far future of the cosmos, not just thousands or millions of years from now, but trillions. The Milky Way has merged with Andromeda, forming a vast elliptical galaxy. The bright blue-white stars that once filled the sky are long gone, their fuel spent. In their place, only the faint glow of red dwarfs remains, their light barely strong enough to pierce the darkness. Around some of these dim stars, planets still orbit. They are the last outposts where life, any life, might endure. These worlds will be small havens in an otherwise hostile universe, like isolated cabins deep in an endless winter forest. The physics of it is straightforward. Red dwarfs burn their fuel so slowly that they can shine for trillions of years, far longer than stars like our sun. They are the cosmic misers, stretching every atom of hydrogen to its limit. A planet in the narrow habitable zone around such a star might retain liquid water for unimaginably long periods. And if life ever arose there, or was carried there by the seeds of panspermia, it could, in theory, outlast every other living thing in the universe. But these planets would not be like Earth. The light from a red dwarf is not golden, but a dull, ruddy red. The days might last weeks, months, or even years, depending on the rotation. Many such planets would be tidally locked, with one side in perpetual daylight and the other in eternal night. The habitable region could be a thin strip of twilight along the terminator, a ring of permanent sunsets circling the globe. Life here would cling to the edge, where conditions are neither boiling nor frozen. It is possible to imagine civilizations on such worlds, perhaps small, slow, patient societies, adapted to the faint light and the long days. They might live underground to escape the constant radiation flares that plague many red dwarfs, venturing to the surface only during the calm periods. Their technology would be optimized for efficiency, recycling every resource, drawing power from every scrap of usable energy. In the absence of bright stars to navigate by, their skies would be mostly empty, a few faint pinpricks of light where galaxies once shone. If we are not the last civilization, these worlds could be where the final intelligences of the cosmos make their stand. But that word, stand, might be misleading. They would not stand so much as endure. In a universe running low on energy, expansion and ambition may give way to conservation and survival. Their civilizations might span millennia between major events, their histories written in stone not because it is poetic, but because stone outlasts everything else they can afford to make. And then, even for these last worlds, the clock will run out. As the red dwarfs burn their final fuel, their light will fade to a dim ember. The habitable zone will contract toward the star until the twilight ring becomes a narrow, frozen band, then nothing at all. Oceans will freeze. Atmospheres will collapse. If any civilizations remain, they will retreat inward, toward artificial habitats powered by the dwindling warmth of their dying star. They will know they are the last, not just on their world, but in the entire universe. And eventually, the star will go dark. What happens after that? Perhaps some will build vast structures to capture and store the last heat from radioactive decay in their planet's crust. Perhaps they will tunnel into the cores of gas giants, mining them for fusion fuel. But each of these solutions is temporary. In time, the fuel will be gone. The planets themselves will freeze solid, drifting through the dark with no sun to bind them. It's tempting to imagine these last civilizations sending messages into the void, hoping another mind will hear them. But who would? By then, the universe will be so stretched by cosmic expansion that even the closest stars will be unreachable. The signals will travel into nothing. And maybe they'll send them anyway, not because they expect a reply, but because, like us, they cannot bear the idea of leaving without saying goodbye. The thought of the last habitable planets is not just a glimpse into the universe's future, it's a mirror for our own time. Right now, we live in the crowded, energetic youth of the cosmos. Stars are still being born, galaxies still collide, and the night sky is full of light. But the same laws that will one day freeze those final worlds are already in motion. The clock is already ticking. And if we are the last civilization the cosmos will ever see, then the last habitable planets are not just science fiction, they are the stage for our own ending. Perhaps we will be the ones huddled in the dim light of a red dwarf trillions of years from now, telling stories about the age of bright stars, the age of abundance, the age when the night sky was full of fire. Perhaps, when our time comes, we will do what every civilization before us may have done: face the end with whatever dignity the dark will allow. There is a peculiar cruelty in the idea of being born into a world, or a universe, just after the great events have ended. Imagine stepping onto the stage after the play is over. The audience gone, the lights dimmed. You wander through the set pieces, beautiful but lifeless, and you realize that whatever story they once told is already finished. In cosmic terms, this may be the fate of civilizations born too late. Right now, we exist in what astronomers call the cosmic noon of habitability, not in the literal sense of time of day, but in terms of the universe's life cycle. Stars are still forming, galaxies are still bustling with activity, and the raw materials for planets and life are abundant. But this fertile era will not last. Already, the rate of star formation is slowing, and the proportion of metal-rich stars, the kind that form planets like ours, will decline as the universe ages. Fast forward 1 trillion years, Most of the large, hot, luminous stars will be gone. The galaxies will be quieter, their interstellar gas depleted. New stars will still form, but rarely, and they will mostly be small, cool red dwarfs. Planets will still orbit them, and some of those planets may be habitable. Life may still arise. But here's the catch. By then, cosmic expansion will have erased the evidence that a greater universe ever existed. Galaxies outside the local gravitational cluster will have disappeared over the cosmic horizon, their light forever out of reach. The sky will no longer be filled with a tapestry of distant suns and galaxies, but with emptiness. If a civilization emerges in that time, they will have no way of knowing the truth we can see so clearly today, that the universe was once a place of infinite light and motion. Their telescopes will reveal only the handful of galaxies bound to their own, with nothing beyond. Their scientists may conclude that the cosmos is small and eternal, that it has always been as it is now. They will be wrong, but there will be no way for them to prove otherwise. Worse still, their opportunities for connection will be almost non-existent. Any other civilizations that existed before them will either be gone or unreachable. Even if life survives in other galaxies, those galaxies will have been carried away faster than light can bridge the gap. For all practical purposes, such late-born civilizations will be alone as if they were the only thinking beings to ever exist. This is not just an abstract possibility. Physics guarantees it. There will be civilizations, if life persists long enough, that arise after the great web of the cosmos has already unraveled. They will never know the universe as we do. They will never see the Milky Way in the sky, because it will have long since merged into a single, featureless elliptical galaxy. They will never watch a supernova light up the darkness, because the massive stars that make them will no longer be born. They will live in a cosmic museum, wandering through relics of a past they cannot witness. Perhaps some of them will sense the truth, that the universe was once more alive, more connected, more luminous. They may find strange background radiation, the faded echo of the Big Bang, and wonder what it means. They may study the orbits of stars and suspect there is something missing, some gravitational tug from things they can no longer see, but the full story will be lost to them. And here's where the thought cuts deeper. What if we are already in this position without knowing it? What if we too are born after the great age of civilizations, the age when life was common and voices echoed across the stars? What if the golden era is already over, and we are the remnants, the latecomers to a party that ended billions of years ago? If that's the case, then our silence is not surprising. It's inevitable. The others are gone. The lines of communication have been cut, and we, like those future civilizations, are left to wander through a universe full of clues but devoid of company. Civilizations born too late inherit the same responsibility as those born early, to preserve themselves, to create meaning in the absence of others, to hold a light in the dark even when no one else can see it. Perhaps that is all intelligence can ever do in the end. Not to save the cosmos, not to change its fate, but to keep the flame alive for as long as possible. For them, as for us, the tragedy is not just being alone, it is knowing that others may have existed, and that the universe's story was already written before they arrived. And if we are the last civilization the cosmos will ever see, then maybe that is exactly where we stand now, heirs to a history we cannot recover, custodians of a light that will one day be the last the universe will ever know. If the last civilization in the cosmos falls, will there be anything left to show we were ever here, or will the universe simply swallow us, leaving no trace, as if our thoughts, our works, our entire existence had been a dream? It briefly forgot upon waking. On Earth, we like to imagine permanence. We carve our history into stone. We launch golden records into space, etching our greetings, our music, our diagrams of the human body into disks meant to outlast us. We send probes like Voyager and Pioneer toward the stars, carrying our fingerprints into the void. But permanence is a trick of perspective. Stone erodes, metal corrodes, orbits decay. Given enough time, Even the most careful craft will be ground to dust by collisions with micrometeorites, eroded by cosmic radiation, and pulled apart by the slow stretching of space. On a planetary scale, our monuments are laughably temporary. The pyramids might endure for tens of thousands of years, perhaps hundreds of thousands, before wind and sand reduce them to anonymous mounds. The Great Wall of China will vanish faster still. Our cities will crumble, our satellites will fall, and the Earth itself will eventually be uninhabitable, roasted by the swelling sun, then stripped of its atmosphere, then swallowed. But what about artifacts beyond Earth? Our spacecraft, drifting in interstellar space, may last for billions of years, far from any star. In the cold darkness between systems, they will be preserved longer than anything on our home planet. Yet even they are not immortal. Cosmic rays will slowly alter their molecular structures. Collisions with dust and debris will erode their surfaces. The expanding universe will stretch their atoms ever further apart until their patterns become meaningless. Some dream of building monuments on a cosmic scale, structures vast enough to survive stellar death, black hole evaporation, and even the eventual heat death of the universe. Dyson spheres, ring worlds, and data storage lattices the size of planets. But here too, entropy is the final judge. Given enough time, no arrangement of matter can resist the smoothing out of energy differences. It is possible that the only memory of us that might last will not be physical at all, but informational, encoded in the ripples of space-time itself. Every movement we make, every shift in mass, sends out gravitational waves, faint beyond comprehension, but real. In principle, these ripples carry a record of our existence into the farthest reaches of the universe. But no one will ever read them. They will be too faint, too stretched by expansion, and there will be no one left to detect them. And yet, there is another way to think about memory, not as an object to be preserved, but as a process. A thing's existence is not diminished by its impermanence. It is made more precious by it. We may not leave a monument that lasts until the last proton decays, but we are the monument now, a temporary arrangement of matter that knows itself, that can look at the night sky and understand, however faintly, the scale of its own impermanence. If we are the last civilization, perhaps our greatest legacy will not be something the universe keeps, but something we choose to give away before we're gone. We could send signals into the void, knowing they will fade. We could leave messages in the shadows of distant moons, knowing they will erode. We could write stories, compose music, map the structure of the cosmos, not because we expect these to endure, but because in making them we affirm that our time here mattered. Even now, the golden record on Voyager 1 is gliding silently through the darkness, carrying greetings in 55 languages, the sounds of wind and rain, the heartbeat of a mother, the music of Bach and Chuck Berry. It will almost certainly never be found. It will not save us from oblivion. And yet it exists. It is our statement to the universe. We were here, we thought, we felt, we tried. In the end, maybe that is enough, not immortality, but the act of reaching beyond ourselves, even when the silence answers back. Not the guarantee that someone will remember us, but the quiet courage of remembering ourselves. When the last civilization in the cosmos fades, the universe will not hold a funeral, the stars will not dim in mourning, but for as long as the light lasts, we will have had the chance to see it, to bear witness, to participate in the great unfolding, however briefly. That too is a kind of memory, not stored in stone or silicon, but in the living moments we are experiencing right now. And if the cosmos will one day forget us entirely, perhaps the best we can do is to make sure we don't forget ourselves while we're still here. The idea sounds absurd at first. A species, a civilization, or even a single mind persisting beyond the lifespan of the cosmos itself. How could you survive the death of everything? And yet, for as long as we've been aware of our own mortality, we've also dreamed of immortality. It was inevitable that once we grasped the universe had a finite future, some of us would start asking, could we find a way to stay when everything else is gone? To even consider this, we have to stretch our thinking across unimaginable timescales and into the outer edges of theoretical physics. The challenge is simple to state. The universe is losing its usable energy. Stars will burn out, galaxies will drift apart, and in the far future, even black holes will evaporate. If we want to outlive all that, we need not only a power source that will never run out, but also a way to avoid being swallowed by entropy itself. One speculative path is cosmic migration. If we can't stop our universe from winding down, perhaps we can move to a younger one. Certain models of cosmology suggest that our universe might be just one bubble in an infinite multiverse. In theory, it might be possible to create or access another bubble, a newborn universe with fresh energy and a long future ahead. The trick, of course, would be opening a doorway across realities without being annihilated in the process. This is firmly in the realm of speculative physics. Wormholes, quantum tunneling, and hypothetical false vacuum transitions that could be as dangerous as they are promising. Another approach is cosmic hibernation. In a universe with dwindling energy, the most efficient survival strategy might be to slow everything down. This is the astivation hypothesis proposed by some astrophysicists. An advanced civilization might spend most of its time in an ultra-low energy state, waking only occasionally to make use of the energy available, then returning to dormancy. The colder and slower you run, the longer you stretch your remaining resources. In principle, this could allow a civilization to experience trillions of subjective years, even as the physical universe approaches its end. Then there are the more exotic ideas: harvesting energy from black hole spin, storing consciousness in quantum systems that can persist far longer than biological matter, or embedding information in patterns of gravitational waves or neutrino streams, carriers that could, in theory, survive longer than atoms. Some even speculate about encoding a civilization into the structure of space-time itself, in the form of stable mathematical patterns that are not subject to decay in the usual sense. And yet, all these solutions circle back to the same looming problem. Entropy doesn't just threaten our power supply, it threatens the very capacity for complexity. Even if we could slow down our thinking, jump to a new universe, or store ourselves in the deep fabric of physics, the slow grind toward maximum entropy means that eventually, all differences fade. Every state becomes the same. There is no room left for computation, no gradients left to exploit. Even the act of existing becomes impossible. Which leaves us with the final humbling truth. Perhaps nothing can outlive the universe, at least not in the way we mean. Survival may not be about stretching our existence to infinity, but about making the most of the time we have. The dream of immortality, cosmic or otherwise, may be less about physics and more about psychology, a refusal to accept that the story must end. If we are the last civilization, this realization is both terrifying and liberating. It means that our future is finite, but also that our actions now are the totality of our legacy. Whether we last another 1,000 years or 1,000,000,000, our time is defined not by how long it is, but by what we choose to do with it. We may not be able to outlive the universe, but we can decide how brightly we burn while the lights are still on. And maybe that's the real escape from cosmic death. Not to avoid it, but to face it without wasting the moments we still have. If the universe were a vast cathedral, then we may be the final congregation still awake inside it. The stone walls of space stretch beyond sight, and the stained glass of the galaxies still glows in colors our eyes can barely grasp. But the candles are burning down. The choir has gone silent. The long service of creation is almost over. To be the last civilization the cosmos will ever see is not a title we asked for, nor one we can confirm. We may be wrong. Others could still be out there, hidden, quiet, surviving in ways we cannot imagine. But the silence we hear when we listen for their voices is so deep, so persistent, that we cannot ignore the possibility that we are alone in these final centuries or millennia of cosmic light. What would it mean truly to be the last? It would mean that when we vanish, so too does the universe's last witness, No more minds to measure the stars, no more questions to fling into the void, no more memory of anything that ever was. The final chapter would be unwritten, not because there was nothing left to say, but because there would be no one left to read it. And yet, knowing this does not need to weigh on us like a curse. It could just as well be a calling. If the cosmos is counting down to its own silence, then we are not just participants in that story, we are its stewards. We can make the record of existence richer, stranger, more beautiful than it would have been without us. We can use our time to fill the fading air with music, to paint on walls that will eventually crumble, to send our voices and our kindness further than we ever thought possible. Perhaps the meaning of being the last is not in fighting the inevitable, but in refusing to let it diminish the worth of what we do now. The heat death will come, the stars will go out, but that does not make our moments under them any less real. It is a strange comfort to think that even if the universe forgets us, we are here now, and the universe is aware of itself through us. For these brief centuries, we are the eyes and the ears of creation. We are the dream the cosmos is having before it slips into the deepest sleep. And if we are indeed the last civilization, then we have one final task to witness: to see the universe as it is, to understand it as best we can, and to leave, even if only in the faintest traces, the truth that it was once alive and aware and wondering. The stars above you tonight may seem eternal. They are not, but while they burn, so do we, and in that shared light, fragile as it is, there is something worth cherishing, worth protecting, worth carrying forward until the very last flicker. Because when the final shadow falls and the cathedral of the cosmos grows dark, the universe will not know that it had once been witnessed, but we will know, and that is enough.